Welcome, guys. Usual cast of characters. Sorry for the background noise. My internet has been acting up, so I'm actually at Starbucks and Panda Express. So sorry if there's no music playing or something, but yeah, we'll get started here in just a couple minutes.
Hey man, at least you've got a Starbucks where you are.
Yeah, I'm pretty lucky that way. I have a couple of them actually. There's one, of course, built into the grocery store too. So it's like there's like three like within walking distance. But yeah, we have a couple of things to discuss today. Let me just actually bring up the topic. I didn't post anything about like the topics because I kept it purposely vague. But let me just go bring this stuff up because one thing. Well, I'll just talk about what I wanted to talk about a little bit was thanks to Brian, thanks to Jonathan Perkin, and thanks to Dan, even if maybe he didn't do anything exactly, he at least gave moral support on this one. We got instructions, and Brian put some improvements in for two-factor authentication for SSH on SmartOS using Google Authentication module. And Jonathan Perkin supported by getting the code into and compiled version into package source along with libqr encode, so it can output a QR code for your app. And then I wrote the instructions. I did it from source code and got it working, and Brian gave me all the help to get it working. And then once it's in package source, the instructions are there. They'll be really nice and easy, so it's great. It works great. It's really, really simple to get two-factor authentication on your SmartOS instances over SSH.
Sorry, where's instructions for this?
Oh, they may not be published yet. So I have the pull request. I'm sorry. I have the pull request, and Brian put some improvements in. I could probably merge it like right now. So let me look at GitHub. Maybe I can push it, and then I will put the link to it. I'll put the link to it in the chat. It's really, really simple. It's like basically you just have to add the PAM module that Google, and it gives you a weird location. So I have to use the absolute location, and then the two lines for SSHD go in there. So let me just double check where that pull request is at. Triton documentation here. 1 second. Apparently I don't know how to use GitHub very well. You gotta sign in. I'm trying to find the page. I'm like, just sign in. Okay, it looks like we passed the little 2-minute, 3-minute beginning there. So welcome everybody to Triton Office Hours. Thank you very much for joining. We've got a good group here. We're gonna talk about a couple things today, and then if we have time, which I don't think our stuff is going to take up too much time, you guys can jump in and talk about whatever you guys want to talk about. If you have projects going on, there's questions you have, go ahead and ask them. Because we just want to cover a couple things, but we really want to get some interaction from the community, hear what you guys are doing, and if you have questions or suggestions, we'll be glad to hear them. So I will just jump off really quick. What I was just talking about, I'll just repeat it one more time. Thank you to Brian, who's on, Jonathan Perkin, for helping me get some documentation written up for two-factor authentication in SSH for SmartOS instances. So the Google Authentication PAM library was already nice and compiled very easily on SmartOS. Like I was able to just bring it down and use the build tools, and it just works. And then Jonathan Perkin was able to get it, that and the libqr encode and the binary for Google Authenticator into a package source. So I need to merge. That's what I was doing. I'm logging in right now to merge the documentation. But we have I got some instructions written up to easily walk you through after you install from package source the next steps you need to do to get it up and running. I put a link to some helper scripts that I just made, one for the source version, but the package source one is in the documentation. You can either run that little quick helper script or just put the lines into SSH and the PAM-conf yourself. And then in the documentation, I recommend do this, have 2 open connections so you don't lock yourself out, because I've already done that a couple times. I've locked myself out before getting, like, I restarted SSHD and like did it and got the timed out on one of my instances, and I was locked out. So don't do what I did. But yeah, it's really, I'm gonna just review Brian's update really quick. And
I didn't get to finish my changes yet. So the documentation for it will get added soon to the Triton documentation website, probably before the end of the day, but it's not quite ready yet.
Yeah, can you just like post it somewhere in one of the channels, because that sounds interesting.
Yeah,
channel for sure. It's cool. I saw that because I was doing it on the Linux instances in Triton Cloud, and I was like, we need this for SmartOS, and then Brian provided a lot of help because he gave me like directions on where to put the PAM configuration line and what it needed to be, and Jonathan provided a lot of support by getting into package source, just making it easy. And I was like, it's actually easier than like doing it for Linux. Like, it's really, really simple. Once you look at the directions, you're like, oh, that's really easy. You just need to PAM the library, run the binary, and just put the right lines in your PAM-conf and SSHD, restart SSHD, boom, you have 2-factor authentication. And then I'll just say in the documentation, it's compatible with any authentication app. So, Microsoft Authenticator, Google Authenticator, but in the documentation, I push you kind of a direction to use 1Password. We use 1Password here at MNX for a lot of stuff, and it has support for one-time passwords too. And so I like it because you're not relegated to just using a mobile app. You can use the browser extension and the desktop app and the mobile app and all of that, and it syncs all between those. And they support one-time passwords. So 1Password is an option if you want. But all the apps that support, the OTHP or what, I don't know, I'm sure what it's called, but the
HOTP or TOTP. Yeah. TOTP is the time-based one where you just have a secret key that's seeded and then it rotates every 30 seconds. And then HOTP is an HMAC one that's incremented. So that's like the recovery codes is the HOTP protocol. So there's like, it's the 2 protocols combined together that make up the like Google Authenticator experience that basically everybody uses nowadays, that you're almost certainly familiar with, where you set it up, it gives you a QR code, you scan it, and then you get a code that you got to type in, and then that will verify that you've got the right code on your client. And then when that's done, it dumps out a bunch of recovery codes that you can use each one time only if you don't have access to your 2-factor device. So the TOTP, time-based one-time password, is the rotating one, and then the HOTP, HMAC-based one-time password, is the recovery codes.
Yeah, so it gives you the backup codes as well when you do the Google Authenticator binary. I don't know if anybody's used it on Linux or other operating systems, but it's really, really simple to configure, and it works really great. And then I got stuck at this one configuration part, which was permit root option. I kept forgetting. Luckily, I figured this out just through some documentation through like Linux, since it's open SSH, so it works similar across platforms, and was able to figure that part out. And then I forgot I didn't write that part down for myself, so I went to go do this process again over the weekend and kept locking myself out from my instances. So just make sure you kind of closely follow the instructions, and then if you do have problems or something is weird, or you can either put in a pull request or say this needs to be updated, or just ping me on Discord or chat or something like that, and I'll be glad to lend a hand if something is not working. But it should work pretty closely with the instructions. So yeah, we'll paste that link where people can grab the instructions. It'll be on docs.Triton Data Center as soon as we get some of the stuff finished, and I just have it under review and have people taking a look and of course, your first submission is never perfect, and I was just saying this to Brian. I was like, I always welcome people to look at it and give suggestions, because when you do instructions, it makes sense to you, but it may not make sense to somebody else, and that's why I like having it reviewed. So we'll get that in later. So that's just one thing I wanted to mention. So that's available for SmartOS if you have instances, or you want to keep any of those instances with two-factor authentication. And then I don't know, Brian, did you want to talk about the vCPU thing?
Yeah. So just on the tail end of the two-factor thing, I was adding in some information about the special handling required for the global zone, and considerations for if you have multiple users that are logging into your instances. So that's going to be in the documentation as well, and that's why it was going to take me a little bit longer than I had expected. Yeah. Okay. So anyway, so the main topic for this week was CPU usage in SmartOS and Triton. And there's 3 controls for instances that dictate what kind of CPU performance that you're going to get out of instances. And those 3 controls are CPU cap, CPU shares, and vCPUs. And they all affect the instances in different ways. So I'm going to talk about each one and kind of how they interact with each other. So the first one, which is the kind of the easiest to understand, is CPU cap. So that's going to be expressed as an integer, which is the percentage of CPU time that an instance is allowed to consume. So if it's a value of 100, it can consume 1 CPU worth. So like if you go into top and you have 8 CPUs on a heavily utilized system, you'll notice that your total CPU usage can be like 700%, which is normal when you've got more than 1 CPU. So each CPU is 100% worth. So I think we're all fairly familiar with that. So CPU cap is the raw amount of time that a zone can consume. So if it's 100, that's 100%. It could go 10% across 10 CPUs. That adds up to 100%. That's your cap. Or it could go 100% on 1 CPU. That's your cap. Likewise, if you've got 400 and 8 CPUs, you could go across all 8 CPUs 50% time, or you could go across only 4 CPUs at 100% time each, right? So your CPU cap can be distributed across any number of CPUs, but your total time is always going to add up to, or can't go higher than whatever the cap is. So often in a cloud environment, we've got these very large, beefy servers with 48 CPUs, 72 CPUs, or whatever. And then your instance is going to be like a C1 dot small, and you've got a 200 CPU cap, right? You can see all of the CPUs, but you're not going to be able to fully utilize all of them. So the next easiest one to understand is vCPUs. vCPUs only come into play on virtual machine instances. So it doesn't apply to joint brand zones or LX brand zones. If you have vCPUs configured in a package that's applied to one of those zones, it just gets ignored. So what vCPUs does is that's the number of hypervisor threads that are run for that virtual machine. So if you have vCPUs 16, we're going to run 16 threads. Okay. Now, each thread can run at most on one CPU at a time. Okay. So if you're whenever you have vCPUs, the CPU cap should be 100x or 100 times the vCPU's value. So if you have 2, then it should be 200. If it's 4, it should be 400. If you have them not in sync like that, so like let's say you have vCPUs 8 but CPU cap 200, your guest is never going to see itself fully utilizing CPU time internally. Okay, because you've got 16 threads, but you can only consume 200% worth of CPU. So all of those threads are going to be spending a significant amount of off CPU time because they can't be scheduled anymore. Because you've hit the cap much sooner than your guest CPU utilization could reach 100%. So, and again, those threads might run on one CPU for an amount of time, get context switched out, and when it's switched back in, it goes back to a different CPU. That's normal. It doesn't mean that you're going to be pinned to a particular CPU. But you want to make sure that your CPU cap is at least what your vCPUs are, so that your vCPUs can be fully utilized. If your cap is less, then you are guaranteeing certain amounts of latency to that VM that it wouldn't otherwise be receiving. And so so the last one, CPU shares. CPU shares only comes into play when there is contention for which thread should be scheduled next. In the case where you have a mostly idle compute node, your CPU shares are almost never going to come into play. But when you have a compute node that's extremely busy and most CPUs are handling a task at all times, and the scheduler is very busy, that's when CPU shares is going to come into play. And the way shares works is it helps the scheduler decide which threads are going to be scheduled and which threads are not going to be scheduled, or will be scheduled later. So the term CPUs may invoke in your mind something like shares in a company, and it's very much like that. Each instance is allocated, and whether or not let's see, how do I want to phrase this? The amount of times that an instance will be scheduled with priority over other instances is determined by that instance's number of shares over the total number of shares on the system. Okay, so let's say, for example, if you have a compute node with 2 instances, each instance has 100 shares. Okay, that's a total of 200 shares. So each instance's ratio is 100 over 200, or 1 over 2, or 50%. Okay, that's equal distribution between the 2 instances. If you had one of them at 90 and one of them at 10, then you have a total of 100 shares. One of them is 9/10 and one of them is 1/10. And so the one with 90 shares would be scheduled with priority 90% of the time over the instance with only 10. Now, more commonly, the scenario that you find yourself in is when you have, say, 30 to 100 instances, and each one has, maybe 100 to 500 shares worth. And so if you have, say, like 10 instances, and they're of varying package sizes, and so you might have some with fewer number of shares and some with a larger number of shares. To figure out the scheduling priority of each instance, you total up the total number of shares across all instances, and that's your denominator. The numerator is the number of shares of at that particular instance. So you might have like 200 over, say, like 8,000, right? And so that's going to be quick math here. Oops. Which would be about 2.5%. So that instance is going to have priority 2.5% of the time during CPU contention. And if you have the case where you have like 100 instances, and you're getting scheduled priority 2.5% of the time, that's actually pretty good. That's pretty prioritized over other instances. So now, if if you have instances that are already at their execution cap, then they're not going to be in contention at that time, if that makes sense. So like something with a 100% cap, if it's exhausted its cap, then it's not going to get scheduled at all, even if it has a higher number of shares. So you could have, for example, let's say 2 instances, one instance, or let's say a system with 8 CPUs, to keep this simple, and 2 instances. One instance has a CPU cap of 700, and one instance has a CPU cap of 100. But the instance with the 100 cap has CPU shares of 1,000, and the one with 700 CPU cap has shares of 10 or 100, right? So in that case, that would give your like smaller like low CPU cap instance extremely high priority over your other instance, but only while it still had CPU time available to spend. So doing something like that, you could get an instance that is kind of acting like in a real time capacity, like whenever it has something to do, it's going to get scheduled as soon as possible. But it often doesn't have something to do, like it's often idle, right? But once it has a task, it needs to be able to perform that task virtually immediately. You can do something like that where you have a low CPU cap and a very high number of CPU shares. That way, as soon as a task comes in for it, it can execute that right away. And then your other task or your other instance that's like 700 CPU cap and low number of CPU shares, like maybe that thing is doing like archive work or like, transcoding or something like that, tasks that are, chewing up a lot of CPU. But if they get delayed by a few seconds overall, in your task that is going to take 20, 30 minutes to do a transcode for a 4K 2.5 hour long movie, right? If it's delayed by 5 or 10 minutes, like overall, that's not really a big deal. So you can tune CPU shares and CPU cap according to the needs of your applications in order to get the best performance out of them. So having like a one size fits all approach to CPU cap and CPU shares isn't necessarily going to be giving you the best performance, right? So something with a high CPU cap doesn't necessarily need to have the highest number of CPU shares. So that's something to take into account with the applications that you have running in your environment and their particular needs. Jasper asks, CPU shares is not a setting you can configure in a Triton package, right? You can only manually set it. No, the FSS fair share scheduler value in a package dictates the CPU shares that are assigned to an instance. And Juicy Panda writes, we found that vHive CPU cap needs to be higher than vCPU count. Virtualization service needs some CPU. Yeah, that's true. Like at Joint, when we were in the public cloud, we would usually have like if you have like 4 vCPUs, we would have CPU cap of 500, so that there was like one whole CPU worth of spare capacity available for the stuff happening outside of the VMM, but still inside of the zone. So yeah, that's a good point, and we built that into all of our packages. Something else, kind of tangentially related to that, is that the zone needs some additional memory on top of the memory that's directly allocated to the virtual machine. And so we always allocated an extra 1 gig of RAM. So if you had an instance that's 4 gigs, we would allocate 5 gigs of RAM to it. And actually, the way that we did it at Joint would be like there was 4 gigs allocated to it, and you would get like 3 gigs assigned in your VM. So yeah, when doing HVM instances, or when doing packages that are going to be used for HVM instances, you want to reserve some for the stuff going on outside of the actual VM hypervisor. Let's see here. Okay, from Marcel, I assume that changes in topology aren't reflected within bhyve, e.g., if there are 2 vCPUs and the bhyve threads swap between 2 cores, the OS within bhyve will not be aware of that. Yeah, I think that's the case.
That is correct.
Yeah.
That is correct. If you really want there are Lumos level abstractions you can use to the pbind command or PR control. Like one of those can bind process threads to CPU cores specifically, but by default that doesn't happen.
Yeah. They're so like not aware of that. We can like kind of stick an asterisk on that because there may be some ways to figure that out. We've seen with things like Meltdown Inspector, you can do some like timing attacks on things to see if like something was cached versus not. There might be ways in there for a thread in a guest to discover that it was running on a CPU and now it's running on a different CPU, or things that it expected should be cached because of what the guest CPU expected the state of the processor to be like versus what the processor actually like. That kind of thing is entirely possible. So I'm not going to say that it's impossible for the guest to know, but it's not expected for the guest to know. So yeah, and I think that you can't even get the CPU UUID from within a guest, like the real one. I think you get fabricated ones. So yeah, I'll say that is mostly true, but not guaranteed, because new timing attacks on CPUs may be discovered that kind of throw our existing assumptions out. So yeah, let's see. Any other questions with CPU shares, CPU cap?
Brian,
CPU,
type
CPUs?
is passed through to the bhyve guest.
What's that?
The CPU information is passed to the bhyve guest.
Is it? Okay. So if you check the CPU UUID consecutively, you might be able to record more than the number of vCPUs
Yeah, but I mean,
that you think you have.
I don't know if the UUID gets passed up, but like I have an OmniOS
Okay.
VM. I have an OmniOS VM, and I did PSR info minus VP, and it didn't print it the same way it would on real hardware, but I definitely see that I'm running, Haswell E underneath.
Oh yeah, there are definitely things that I know are passed through.
Oh, okay. Sorry,
But like
I that my bad.
Yeah, I'm not sure if CPU number is something that's passed through, or CPU UUID is something that's passed through. So yeah, there's something else. Oh yeah. Okay. Within Triton, if you have a very small installation, like at my house, I run Triton on Intel Nukes. They're very small, 2-core, 2 hyper-thread systems, so 4 virtual cores. So I've got at most 400% CPU that can be consumed on these things. And my applications are mostly idle almost all the time. So the default behavior in Triton is like if you've got 4 virtual CPUs, you can provision at most 400 CPU cap worth onto those things. And what I found was in order to get like the density that I wanted, I had to have extremely small CPU cap. Because if I put CPU cap of 100 to give something even moderately reasonable performance, I'm only allowed to put 4 things there, and I want to be able to do way more than that. But setting my CPU cap to something like 10, so that I could put like 40 instances on one of my nuke compute nodes, the performance was just absolutely terrible because everything was getting throttled all the time, even when it was doing virtually nothing. And so there's a setting in SAPI that you can tell it to ignore CPU cap. And so I have on my Triton at home, ignore CPU cap. And so for my stuff, the only thing that comes into play is CPU shares and vCPUs for my virtual machine instances. So if you have something that's very small, or if you have a fully trusted environment that people are not going to be complaining about noisy neighbors, you can turn off a CPU cap from consideration.
Quick question: is that setting? Is it like it's either on? Like, is it a global, or is it like you can do it per instance?
It's Triton global. Yeah. Yeah, so if you have that setting, it's basically a setting that applies to the designation API or designation algorithm, which it used to be a standalone Triton service. Now it's a subcomponent of Canapi, but the repo for it is SDC designation, or sometimes we will kind of colloquially refer to it as DAPI, the designation API, even though it's not an API anymore, it's just an algorithm. So when you apply that setting in SAPI, then DAPI will ignore CPU cap when it's running the designation algorithm. And so that's basically the way it works. Another thing about CPU caps are that if you have a package that has no CPU caps, and you have CPU caps enabled in SAPI, which is the default setting, or in other words, you have not turned off CPU cap consideration. An instance that has no cap is exactly that. It's unlimited, and therefore all CPU cap on that compute node is considered exhausted. Okay, so if you have a compute node with 8 vCPUs, you put an instance on it with a CPU cap of 400. There's 400 available, so the total is 800 for your 8 CPUs. An instance with 400 is reducing that by 400, and so you have 400 available. Additional instances added to that compute node must be less than an additional 400. Okay, so you can only add an additional 400 worth. You could add 2 200s, or 4 100s, or 8 50s. But if you put one instance on there that's unlimited, Triton considers that as consuming all available CPU. Okay. So if you're the default behavior of Triton is that if you have packages with no cap, those can only be co-located with other packages that have no cap. Okay. So Robbie, you had asked, like, is it this no cap thing a global setting or not? In SAPI, it's a global setting, but another way that you could approach this is you have a set of packages that are no cap, and then you trait them as no cap, and you have some compute nodes that are designated for no cap instances, and you trait them no cap. Okay. And then when you pick a package that has the no cap trait applied to it, those will get scheduled onto compute nodes that have no cap applied to it. Okay. Then all of the instances running on these no cap compute nodes will have no CPU cap. Okay, and so you can schedule like you can have any number of instances on there with regard to CPU cap. You're still even capped on like memory and disk space, but CPU cap won't be considered for packages without a cap going to compute nodes with the no cap trait, right? If anybody's unfamiliar with how traits work, maybe we'll do that for an upcoming office hours. But so you could segment your compute node population into no cap compute nodes and cap compute nodes. So all of your instances that have CPU cap would go to the cap CPUs or the cap compute nodes, and all the instances that specify packages that don't have a cap would go to the compute nodes with no cap. And then you can schedule multiple instances onto those compute nodes that have no cap applied to it. So the behavior of Triton is you either need no cap or all cap for a particular compute node. But if you mix cap with no cap, then that compute node is considered full no matter what. So like you have a compute node with your 8 vCPUs, and you have one instance on it with a CPU cap of 50. You put a second instance on it with no cap, that CPU is full, or that compute node is full. Even if it's using like only 128 megs of RAM and 30 megs of disk space, right? It's virtually nothing. But because it has no cap, and there is a co-located instance that does have a cap, that compute node is now full, right? So you want to avoid that situation, and you can segment your compute nodes by using traits. So that would be one way to approach it, or to just globally disable CPU cap by setting the SAPI setting, ignore CPU cap. So, and again, that really should only be used for very small installations or installations with very small compute nodes. It's not something that's appropriate for a public cloud. Like we can't do that in MNX. We couldn't do that at Joyent. So because if you have no CPU cap, then people are going to start using like all 72 cores on your system, and when something else gets added to the system, and now that other thing starts consuming 2 cores worth, and now like the first tenant that previously was getting all 72 cores now is only getting 70 cores, they're going to be pissed, right? So in an environment like a public cloud, there's some like expectation setting. You need to make sure that people are getting the performance that they're used to, because otherwise you're going to end up with extremely unhappy customers. So in a business environment, kind of depends on your users and the expectation that you set with those users. I'm sure there's going to be some people within organizations that, if they see their average CPU utilization like drop down by 20% because a new instance got scheduled co-located onto the same compute node, they're going to be upset about that and complain. And so like CPU cap enforcement is really the only way to guarantee that people can't go above a certain threshold, so that when other things are added to the system, they're not going to see their own performance affected.
You don't want angry coworkers or angry customers.
Right. Yeah. Let's see here. I think I've covered it all. More information about this is in the Zone CFG man page, where it covers talking about CPU cap, CPU shares. I don't think it talks about vCPU. It might, I'm not sure. vCPU is in the VM80M man page. And there's some information about CPU cap and CPU shares in the VM80M man page. But the more like detailed under the hood description of it is in the zone config man page. And then if you want more information than I provided or in this talk or could provide in this talk, there's always the source code to deep dive into, to figure out like exactly what kinds of decisions the kernel is going to be making in, whatever edge cases you're running into.
On the source code, are they would this be in the JS files for those, or are they C?
Oh no! This is C. Yeah, this is deep kernel stuff. Yeah. So in summary, CPU cap is the number of or the amount of CPU time an instance can consume. vCPUs is the number of threads run for a HVM instance. In the guest, if you have vCPUs 4, in the guest, you check the number of CPUs you have, it'll show up as 4. So if you have vCPU 16 inside the guest, you'll see 16 CPUs. So each vCPU thread run by the VMM application, whether it's bhyve or QEMU, that's going to show up as a whole CPU inside of the instance or inside of the guest operating system. And the if you have hyperthreads, so you're like 2 CPU, like 2 die, 2 core system, like that would be 8 CPUs, right? With hyperthreads enabled, that's going to show up as 16 virtual CPUs. So you'd have 16 CPUs on that system to like dole out to everything. And so the guest doesn't see virtual CPUs. It's going to see all of those as like actual like hard CPUs. vCPUs, number of threads that are run, and the number of CPUs present inside of the guest. And then CPU shares is comes into play only when there's contention for the CPU. And the scheduling priority is a ratio of the shares for that instance over the total number of shares across all instances for that compute node.
A quick question. I haven't used Docker for some time on Triton.
Mm-hmm.
How do you select packages for the Docker? Is that in the Docker stuff, or is it like an option that you set the package or something?
Yeah. Okay. Let's
There's a
pin that
label
for a
for that, I
second.
think.
Yeah. Let's pin that for a second because that's like not really related to the CPU performance topic. I want to ask it. Does anybody have any other questions about CPU cap shares or vCPUs before we move on to the Docker question, which is a good question, by the way. Going once, going twice. Okay. If you have any more questions for that, you can go ahead and feel free to raise them again later. But what were you going to say, Ravi?
I was just going to say the reason I was asking out, I mean, in that related to that is that, because I know, like, for instance, like a demo that I think Casey had done a long time ago. He's like, yeah, here in Docker, you can, he ran like HTOP or something and showing, you can still see the CPUs and all that. So I was just curious because, like, I haven't used it in a while. So
yeah, and actually, this topic came up because somebody was asking about running a JVM inside of a container, and the JVM sees 72 CPUs, but the CPU cap was only 400, and so like the JVM was like, oh, I'll just run 72 threads, like this is going to be awesome, and then like each of those threads are choking out all of the other threads because they didn't have enough capacity allocated to it, but so in Docker, Docker on Triton, there's two ways to pick a package. First is there's a setting for the Docker package prefix. Okay. And so what that does is when you specify some amount of memory for your Docker instance, Triton will look for a package that uses that prefix and has at least as much memory as you are requesting. Okay. So if your Docker prefix is, Docker packages, and so you might have like, Docker package 1 gig, Docker package 2 gig, Docker package 4 gig, Docker package 8 gig, right? And so each of those Docker packages has that much RAM assigned to it, or memory cap assigned to it, right? Each one's going to have like some amount of vCPU, some amount of disk space, or not vCPU, but CPU cap, CPU shares, disk space, and memory all allocated to it. And so if you say like, I want my Docker instance to have 3 gigs of RAM, it's going to look up the packages that have that prefix, and it's going to pick the next package up for the amount of RAM that you requested. Okay. So if you requested 4 gig, it's going to give you the 4 gig one. If you requested 2 gig, it's going to give you the 2 gig one. If you requested 3 gig, well, that doesn't fit nicely into the 2 gig, but it does fit inside of the 4 gig, but the 4 gig's more than what you asked for. We're going to give you the 4 gig one. Okay. So that's kind of the default behavior. We will like auto magically guess what you mean. So if you don't do anything other than specify memory, that's how it's going to work. But there is also a label. So you when you do your Docker run command, you can apply arbitrary labels to the instance at create time. You can use a label to specify exactly which package you want, even if it's not one of the like Docker package ones. Like it doesn't need to match the Docker package prefix specified in the configuration. You can choose any package using the label. Yeah, and then the documentation was dropped in the chat there. Yeah, and the label is com.joint.package, and then you can specify the package name of any of the packages available. And I think, I'm not 100% sure, that also supports specifying the package UUID. So you could do that as well. Like if you're using like if you're trying to automate it with some scripts or whatever, whenever you're doing automation, I recommend to use the UUIDs of things rather than the names, because sometimes the names might change out from underneath of you. But I don't know, depending on your perspective, like using the names, you might want to use the names because the UUID might change underneath of you. But I don't know. my preference is kind of for the UUIDs. So anyway, so that's how it would work. Is the less effort way is you just pick your memory size, and Triton will automatically choose an appropriate package that will work for you, or you can add the label that will explicitly select the package size you want. Jasper says, curious about how hard it was or is to manage CPU over provisioning and boosting with these controls in a public cloud environment. Yeah, so it kind of depends on what pain in the ass you want to suffer. If you Canopy has a default over provisioning ratio, and I think for CPUs it's 1, which means no over provisioning. But you can specify an over provisioning ratio of like 1.5, and then if you have say 16 CPUs on a system, you could provision 1.5 times of that. So it would be like 1600 would be the CPU cap available on that system. You could provision up to 2400, right? And so you're over provisioning on CPU. Now, what you're going to run into in that situation is the system ran out of physical capacity before the instances are actually reaching their allocated capacity. Okay, so you having like 1.5% over provisioned, and if everything is running at full blast, they're only going to get about 66% CPU utilization inside of the guest. Like they're going to flatline at 60% CPU utilization, or 60% of their total cap. Okay. Because you ran out of physical capacity first. And the CPU shares is going to come into critical play here because you're at CPU contention more frequently. Okay. So if you over provision, then CPU shares becomes critically important. And that's basically going to decide who gets to overuse more than other instances. And it's really like it's kind of a decision that each installation needs to make on their own, or each organization, because like there's no one right answer for how that should be done. Like I gave the example earlier of like an instance with an extremely high CPU shares but an extremely low cap, because like that's kind of the performance profile that you want for that kind of an instance. Everybody's got different needs within their application, and it may be reasonable within your environment to over provision on CPU. Yeah, but maybe that's not the case. So the default for Triton is to not over provision. But if you have a situation where you know that most of your applications are going to be running idle most of the time, but they still need to exist, then some over provisioning is probably a good idea. But it's kind of it's really on a case by case basis with regard to your applications and your performance requirements with your downstream customers. So that's something that each organization needs to figure out what's best for the workloads that they're running. Yeah, Kokesmi said, know your workloads, know your customers, know your performance latency profiles. I mean, that's it. Like that's really the key thing. And that's why I wanted to talk about CPU performance and these three toggles to help you understand how to build packages that are going to match the correct performance profile for the applications that you need. So yeah, that's a perfect a perfect summary there. Lots of times in the past, like on IRC, people would just say like, "Oh, well, just like tell me what joints packages are because I want that." And I'm like, "Well, I could tell you, but you don't want it really. Like you want to create packages that fit your workloads." And yeah, you really do need to understand exactly what your workloads are so that you can create packages that are appropriate for it. Something that works in a public cloud, I mean, our packages are really generic and kind of blunt, but that's kind of like what we need in a public cloud. For private cloud, you can really fine tune your packages to get the absolute best performance you can for all of your customers, which are going to be like tenants running instances, so that they can get good performance for their customers, which are people with phones using their app, interacting with your server side applications. So anyway, we're about at time here. So I don't want to blather on too much longer. I have packages named.
Yeah, if you have questions or topic ideas, go ahead and drop them into Discord, IRC, any of the channels. We'd love to get some more ideas and discuss projects, things that you want to hear about. Obviously, like traits and stuff that we've dropped in chat, I see. So, yeah. So, just wanted to say thank you, everybody, for joining. And we hope to see you on the next office hours. We'll be posting things about that. So, thank you, Brian, for discussing the vCPUs. And thank you, everybody, for joining in.
And if you have a question that's more complex than we can go over in chat, we'll schedule that for a future office hour session. So, and with that,
Thanks, everybody.
we'll see you all next time.